Here's an example of an area conversion problem, and I'm going to make this intentionally harder in terms of the way I convert from square feet to square meters, or from square meters to square feet rather, just to emphasize the technique. So if we have 250 meters squared per house, and we want to know how many square feet that's worth, I'm going to start by converting from meters squared to inches squared. And that means that after I've looked it up, 39.37 inches approximately per meter, and I'm going to need to square that, because I want the meters to be squared, so that's per 1 meter, and I want the meters to be squared. I'll show just below how we're going to formally do that. And then that would get us into inches squared, and then I could go into feet squared. So there's 1 foot per 12 inches, and I'm going to wind up squaring that. Now, if you write this out, what you're going to get is 250 meters squared per house floor plan, and you're going to get 39.37 inches per 1 meter times 39.37 inches per 1 meter. Now notice that means the 39.37 is squared as well as the inches being squared. The 1 is also squared, but you wouldn't notice. And we're also going to do the conversion of 1 foot per 12 inches. This is a little safer way to do it, is to write out both the conversions. Now, of course, you could write, it was poorly written, so just a moment. You could actually write that 1 square foot is 144 square inches, which you'll find if you multiply the 12 by 12. However, if you write it like this, you will formally see that the meters squared is going to cancel meters times meters, and the inches times inches is going to cancel the inches times inches. And now we get formal numbers of 250 times 39.37 times 39.37, all that being divided by 12 times 12, which, if we sort this out with a calculator, we could do this with leading digit estimation problem work, but let's get a nice precise number. And that's going to get us 2,690.97 or so feet squared. So in other words, a 250 meter squared house is approximately 2,691 feet squared. What that tells us, if you look at those numbers, is that 1 meter squared is approximately 10 feet squared. And that makes sense because a meter is a little bit bigger than a yard, which means that each meter is worth a little more than 3 feet, which means 3 and something times 3 and something, a little more than 3 times a little more than 3 is approximately 10. So a rule of thumb or a guideline for converting from, let's say, European meters squared to American feet squared in housing would be to simply multiply by 10 to get a rough idea of the square footage of a house given to you in square meters. So if you were going to vacation in France, for example, it would be nice to be able to do that, so you'd know the apartment or house and roughly what its size was. Here's a volume conversion problem. So formally, this is going to be Rubik's Cube per swimming pool is our answer, is the units for our answer. So it's going to be RC per swimming pool. And I'm going to need to look up a couple of numbers. I'm going to assume, by the way, then, that a Rubik's Cube is approximately 3 inches by 3 inches by 3 inches. That's a rough guess. Let's pause to look up the Olympic-sized swimming pool dimensions. Though I believe it's 50 meters long, and then the depth and the width I'm not sure of, so I'm going to look them up. Pause for a moment. So it turns out an Olympic-sized swimming pool is 50 meters. So the pool is going to be 50 meters, as I thought, and 25 meters wide. 25 meters wide. And then it has a minimum depth of 2 meters and a recommended depth of 3 meters. So we're going to go with the 3 meters for the depth. So that means we're going to start by saying that a Rubik's Cube, so one Rubik's Cube per 3 times 3 times 3 is 27 inches cubed. And now we need to get from inches cubed into meters cubed. So we do know this conversion from the previous problem that a meter is 39.37 inches. So we're going to do 39.37 inches per 1 meter, and we're going to cube that. And that means we're going to then multiply. That's going to get us into meters cubed. And we're going to multiply by 50 meters times 25 meters times 3 meters per one swimming pool. One Olympic-sized swimming pool, which we'll abbreviate as OSSP. So if we're going to multiply out these numbers correctly, so what we're going to find is that we have the inches cubed. Those inches are being cubed, and they will cancel with these inches. And these meters right here are being cubed, as are these. And so that's going to cancel us with the meters, and so the 3 meters multiplied by each other. And so we're going to have a Rubik's Cube per Olympic-sized swimming pool, which means that our numbers are going to be 39.37 cubed times 50 times 25 times 3 over 27. Now again, we could do this with leading digit approximation. I could cancel the 25 and the 27 to get a rough idea, and that would be a pretty reasonable thing to do. But let's just go ahead and calculate this out. I'm going to pause it, and we'll take a quick look. Okay. This product gives us approximately 8.5 million Rubik's Cubes. To verify this, we could do this in leading digit approximation as well. So let's take a quick look at that if we were to do that. 4 times 10 to the first times 4 times 10 to the first times 4 times 10 to the first. Those are the 3 39.37s. Times 5 times 10 to the first. We're going to cancel the 25 and the 27 and say they're approximately the same. And that means that we're going to have times 3 left over. If we put all the numbers together, we're going to get 4 times 4 times 4 times 5 times 3 times 10 to the 1, 2, 3, 4. And that's going to get us, if we think about it, 5 times 4 is 20, 4 times 4 is 16, 3 times the 16 is about 45, so that's about, it's a little more than 45, so call it 4.5 times 10 to the first, and then the 5 times the 4 is a 20, so that's 2 times 10 to the first, and then another 10 to the fourth. And what we're going to get is 2 times, 2 times 4.5 is 9 times 10 to the 6th. So this is approximately 9 times 10 to the 6th, which is a pretty good ballpark number equivalent there. I hope this has helped.